Hello everyone, my name is Thuy Ninh Dao, and on behalf of the authors Nguyen, Tuyet, Dung, Nguyen, Quan, I'm pleased to present the project names Concurrent BIM Exchange Information Requirements Supports Life Cycle Return on Investment Measurements. Evidence from public building projects in Vietnam. And we're from Hanoi Architecture University and Hanoi University of Civil Engineering. For the presentation now, I present the research problem, the research gap, methodology, evidence, frameworks, and implications. And the talk focus on why life cycle building information modeling return on investment cannot be measured unless exchange information requirements create reliable evidence. So why we do this research? The BIM promise value. BIM is expected to reduce cost, time, rework, and information loss across the asset life cycle. And the return on investment is usually measured after BIM implementation when data may be already incomplete and their return on investment is hard to improve. And the third one is exchange information requirements are critical, and it defines what information must be produced, exchanged, verified, and reviewed. And then the owners cannot measure life cycle BIM value without traceable information from procurement onward. So what is the research gap and the contribution of our research? The existing study post hoc BIM return on investment, the cost saving, the work reduction, and schedule gains. Missing link. Do the exchange information requirements are specified the evidence required to measure life cycle return on investment. This paper is reframe. This paper reframe BIM return on investment as information governance capability, and the contribution is the connection among exchange information requirement, ISO 19650 information governance, and the owner-oriented life cycle. Three research questions raised in this research are do current information exchange information requirements contain information requirements needed for life cycle BIM ROE. The second question is which information capabilities are missing, weak, or unevenly developed. And the third question is how should public procurement exchange information requirement involved to support owner value measurements. The study objectives evaluate procurement stage exchange information requirements from the owner life cycle return on investment expectation. The conceptual reframing BIM return on investment as governance capability, the conventional view, the core argument, and the new view of our research. First, BIM return on investment is calculated after implementation as a financial or performance outcome. The core argument is that return on investment depends on measurable, traceable, accountable, and continuous information. And the new view is BIM return on investment is enabled by procurement stage information governance. The methods used in this research. First, the documentation BIM enable public procurement package. Then we coding the directed qualitative content analysis, and then dimension the five return on investment enabling information capabilities, and then comparison the feasibility study, design, and appraisal, and then scientific The Lifecycle ROE enable exchange information requirement framework, and purpose is identifying whether procurement requirements create area for lifecycle BIM return on investment. The empirical dataset, uh, first in IB 974 healthcare B BEP CDE class report quantity extraction, and then IBL 129 the healthcare EIR LOD 200 ISO 19650 CDE, and then IB 986 public housing design. We study on LOD 300 350 BIM 4D, BIM 5D, and CDE, and then IB 707 public building design, BIM modeling and capability criteria, IB 686 healthcare appraisal, BIM model appraisal and checking staff. 5 BIM related procurement cases across a feasibility study, design, and appraisal research. Analytical framework, 5 coding dimensions, strategic value alignment, performance measurability, information traceability, lifecycle continuity, governance accountability. For strategic value alignment, the owner's objectives and expected value. And for performance measurability, the KPIs output, the reports, criteria, information traceability like CDE, versions, IDs, approval, and for lifecycle continuity, the handover, O&M, AIM, reuse, and for the governance accountability, the roles, the ownership, the review and approval. And the findings, the capability by procurement stage. We figure out the strategy value, the measurability, the traceability, the continuity, accountability, the result, as you can see on the table. For the strategic value, SS strong, and the design most strong, and the operations weak. For all of these 5 capabilities of the bracer are weak, and for the measurability, the design most strong and FS most strong. The traceability, the FS strong and design mix. Continuity, the design mix and the FF moderate. Accountability, the FS is strong and design most strong. So the design step procurement is strongest. Operational procurement contribute least to life cycle return on investment as well. For the package level heat map, according to five factors: statistics, measurable, traceable, continuity, and accountable. The package combine the strong package combine modeling, value, objectives, measurable outputs, traceability, continuity, and responsibility. Is illustrated on IB 974, IB 129, IB 986, IB 707, IB 686. As you guys can see on the table. So the main finding: delivery infrastructure, measurement infrastructure, the current exchange information requirements increasingly specify like B models, LOD, and IFC exchange plus reports and quantities, the CD workflows and BIM roles. The current EIR, the current exchange information requirements, rarely specify like lifecycle return on investment indicators, the owner value baseline, operational KPIs, post handover accountability. So they deliver information but not yet consistently make life cycle BIM value measurement. So proposed life cycle return on investment enable exchange information requirement is shown on the slide. First, the owner value, then the information requirement, the exchange information requirements, provision, and the governance, and the last one, return on investment evidence. Then we can figure out the business operation exit goals, and then the information required are OIR, AIR, PIR, and EIR. The the extra information requirement provision are deliverables, standards, role, CDE, and the governance can measure traceable and countable, and then the return on investment evidence are saving, handover, and performance. So the so ISO 19650 environment CDE information standard delivery planning and six components of ROI enable exchange information requirements are owner value, life cycle KPIs, traceability, operational data, accountability, contractual governance. Practice shift procure BIM as information governance, not only as modeling. So the conclusion, life cycle building information modeling return on investment is not produced by BIM adoption alone. It's enabled when procurement stage exchange information requirement translate owner value into measurable, traceable, accountable, and continued information. Thank you so much for your attention, and we hope to receive your questions and discussion. Then we can improve our research and in our future research as well. Thank you so much.